Hey guys, I just wanted to give you some quick tips and hints about completing the mathematical analysis. Hopefully you are able to follow the steps using the hint to write down your steps 1 through 4. Um, Once you get to step number 5, expansion of your slope equation before plugging in values, you can combine steps 5 and 6. So tip number 1, I want you to just go ahead and use the linear regression value from pivot. You know how we used the log or pro value before. So, and then this is for step numbers 5 and 6. So an example would be you had a slope value of 1.3 from the pivot tutorial, and then you would include the units. Example, newtons per gram. And those would be the slope values, the slope units for the net radial force versus mass. Okay, the next part you're supposed to do, number 7, is to reduce the units. So I'm not going to do that for you, but I am going to give you another tip. So tip number 2 is to remember that a newton is equal to a kilogram times a meter per second squared. Okay, so you'll need to plug in for the newton and then reduce the units that way. Hopefully you don't have a y-intercept and you're evaluating your linear graph, because we only do a mathematical analysis for our linearized graph. So tip number 3 is, even if they give you a y-intercept, look to see if it's really small, because if it's really small, we can approximate it to be 0, and that'll give us a direct proportion. All right, now here, the trickiest part. Hopefully at that point you can substitute, you go back and substitute to write your specific equation with the reduced units. But then for step number 10, we're trying to figure out what is the slope significance. Because we want to generalize that numerical value with the units that we had for the slope into something that's related to more generalized variables. So to go through our slope significance, where 1, this will be my 4th tip, tip number 4, is to examine and write down the constants, and there are 2. And include the units. So as an example, for this one, you would say, oh, well, the mass was the independent variable, and the net radial force was the dependent variable. And so the radius was constant, and so was the speed. The radius would have been in meters, and the speed would have been in meters per second. So you would write down the value for the radius that you used, and then the value for the speed, the constant speed. And then you're going to examine the reduced units. And to the constant units. So how do the reduced units from your slope compare to the units on your constants? So you're going to need to combine those in some way in order to come out with the units that are the same. And then lastly, once you have a combination of the constants that will give you the same units as your reduced units, you want to compare the value of your slope to this new combination of units. So you're going to compare the value to the slope value. And once you do that, hopefully if they're about the same or pretty close, then you know you have the right combination. So just as an example, what I'm talking about here is if you were to multiply, let's say, the radius times the speed, this is not the answer, but an example of what I'm talking about, what units would you end up with? Well, the radius is in meters and the speed is in meters per second. And so if you take the product of the radius and the speed, you would end up with units of meters squared per second, right? So you would ask yourself, are these the units, the same units as the units I got on my slope? If not, then this probably is not likely the combination or the slope significance. Big difference on this one is that the slope significance isn't just one variable, it's a combination of two variables because we had these two variables that were constant. All right, good luck to you. I know you can do it. I'm proud of you. And if you can't, or you get stuck, or you have some good questions, just email or send us a message on Google Classroom. See you later, guys.